Yo, what's up, everybody? I overslept a little bit today, so just woke up, so we're gonna do a little bit of a slow start in today's stream, but this is what we're mostly going to continue with today. We're gonna utilize the activity texture, which we already are, with the snow here, and we can see if we can improve the deformations a bit, figure out if we need some additional data in the activity texture, or if we need to structure it some other way, or yeah, a lot of things. But I mean, this is where we left it off at the end of yesterday's stream, and I think it's already looking pretty good. It has a lot of potential. So let's see here. I just have to mention this as well. You can see we have a little bit of banding, visual banding here on the snow, and that's related to the precision we saved data with. So with this precision, and by not reading the data in a bilinear fashion, this is pretty much the best we can get when it comes to the height here. And it's not only for the snow, it's for the terrain as well. Which makes me wonder if this is the type of data we might want to... Either we want to maybe use 16 bits instead for height, if we store it as compute buffers, or if we store it as a texture we can manage with 8 bits, but we do a bilinear read instead of a point, or we do a bilinear sample instead of a point sample. But maybe we will explore that today, maybe. But we will see. But let's start with the snow, and we have a few tasks here concerning it. This and this is done. We could probably move on to this one. But to properly do this one, we're gonna have to... We are gonna have to sample... I think we could manage with... four additional samples, but I think we're gonna go with 8. So to recalculate the normals and tangent and bitangent, we need to get the height of the neighbors. So let's just start there. And it's basically the activity data that controls the height of it. The activity data together with the mesh itself. So we should probably do something like so a simple for loop right about here. And we want I wonder if I want to store it like this. Yeah, maybe I do. Float 3. Actually, do we do it in water? I think we do. So we want to do something similar to this. Good morning, Geralt. Good morning, good morning. Here we just add the values, but we want to do something like I don't remember the syntax for this in shaders, but positions in object space. Can we do it like this? And then we pretty much want to do all of this for all of these. Displace amount, we're going to wait with a bit. So let's just put it like this. And here we want to set do 1 minus I j plus is what we want to do. Something like this. We want to define the size here as well. Let's figure out that. I'm pretty sure this is not the correct syntax. We'll get to it, but let's see here. We need to offset the UV as well. But other than that, this one sucks as well. Yeah, we're gonna have to. We're gonna have to read the terrain data here as well. I'm pretty sure. But that's okay, that's okay. Let's figure out this one first of all. um, compute, yeah, maybe. Is it something like this we want to do? Okay, beautiful. So we're gonna read 3 times 3 positions. So here we will get the activity data. And then we need position OS, yes. Secondary array dimension must be explicit. Is it seriously just like... Oh, yeah. We manage... Is this enough? Yes, okay. Displace amount here. Let's define it. Float. Okay, beautiful. And then we can do... Positions OS 1, 1. What's up, Cooler SK? And then I also want to do output displace amount. We don't store this one currently. SK up to be nervous. Oh. Why so? Nothing too serious, I hope. So when it comes to displace amount, I don't think we don't want to store this for all of the different. For now, let's just do a real quick if I is equal to 0 and j is equal to 0. Main displace amount. Cooler Escape father passed away 2 days ago. Damn, that sucks, man. I'm sorry. I'm in charge of all arrangements for burial. Yeah, I'm sorry, that sucks. Yeah, that's pretty much everything one can say. That sucks, man. I'm sorry. And not that it's gonna get buried, you want it to be cremated. Yeah. Yeah, I can imagine, like, there's a lot of things that needs to be done. And pretty much just at the worst time, right? RSK, that snow looks good. Thank you. It has potential for sure. I think it already looks quite good, but we want to get it a little bit better. And better the one outside here. Yeah, I was about to say, here in the south of Sweden, we didn't get... I think we had snow for 1 day this year. So I'm compensating a bit by implementing snow in this game. So I can... So I can enjoy it a bit more than just 1 day, you know? Okay. But we have snow here that looks exactly like it did previously. It's just that we have made the initial work to get... to improve it a bit. But we need to do more stuff here. But to be able to do it properly, we need to send in some more things. We need to use the terrain data because we need to get the height of the positions neighboring this position. so we can properly recalculate the normals and stuff. So we're gonna have to we're gonna have to include this one. Cooler weather been in positive temps this entire week. It all melted away. Yeah, like it's the same here in Sweden, especially here in the south. We have had it's pretty much been in the positive temps this whole winter. It's a little bit sad having a full winter without any snow at all, you know. At least you had some, I reckon. Okay, so we want to include this one. Terrain. Did I call it? Base data. Including this one gives us some functionality to read it, but we still need to send it down to this shader or set it in the shader. And we're gonna do it by... So it's these two we need to set. And we need to set it down here. I don't think I have a nice way to do this, so we're gonna destroy terrain patch a bit more. I wonder if we can do get terrain buffer here, but this one is private, that's what I'm talking about. We can get specific values here, but not the buffer. This one is get protected set. We had some over New Year with big fluffy snowflakes, was perfect winter weather. Oh, love it. Love it. Snow, especially snowing. So snow together with it actually snowing on Christmas and New Year's. It's pretty damn nice. Yes, we're gonna need both of these, which unfortunately makes me want to do this as a public, but it feels like underlying data and how we handle it, it's ever changing. It feels like I never converge towards something that just bad planning on my part, I reckon. But if we do this, we can get the correct buffer in terrain base and properly set it here. Set buffer, patch dot buffer, and data type height. But then we want the name of it as well. And I don't think we have it here, so we're going to do another magic little string. Or actually do, oh, maybe we do, maybe we do. Maybe I've done it in such a nice way so we can just do terrain patch buffer terrain data type height dot name, or maybe it's just terrain data type height buffer size name buffer name. That's pretty cool. This one returns a terrain data buffer. We want the compute buffer. Something like that, and then we need to do set vector and we have this name here. Oh, no. Terrain data type dot height dot buffer size name. The material copy set buffer, material copy set vector. That should mean that we now have access to this, and I want to try it real quick. Can we do okay, but we want to do this one. Return get terrain base data input.uv.r, or actually dot height. Does this look correct? I think it does. And if we do that, looks to be all right. But we need more information from the CPU. We need, let's see here. Morning, Harukanan. We need, I never remember what we call these here, but we need the delta distance to the neighbors, X and Y, and then we need, yeah, that's all we need to send down. But then here we also need to recalculate UV step. But this should be as easy. We can check, I think we do it in the water, so we can just check how we do it here. Scene texel size. Texel size. We just do it like this here. Okay, but let's take this one. And actually, now when I think about it, rain-based data HLSL, get index from UV. Terrain data packing. So what I'm getting at here is, instead of using the UV to fetch the data from this compute buffer, could we just work with indices from the get-go? So instead of transforming indices to UVs to indices, but this is one-dimensional index, so we have to keep that in mind. And then also, unfortunately, I think we're gonna have to clamp this one as well. The more I work with this one, like having some data in compute buffers is probably preferable, but some data we would probably like to have in textures as well. So when it comes down to it, I wonder if we want to abstract it even more. Now, let's just work with compute buffer for now, and I need to think about it. Okay, so let's do this, and then we want main base data. Yeah, we have to be careful here so we don't try and read out of bounds. But we can probably clamp the UVs instead, so make sure that this one is between 0 and 1. So we can handle it here. But we still need which means that we want to do a saturate here, which is not ideal. Yeah, now we will read activity data from the point itself and its neighbors, I think. But we also need to read the positions if we want to calculate the normals. Or actually, there exists if we 4 connected neighbors. Yeah, if we don't do it depends on what neighbors we use. If we need a distance between them or not, I think. If we do connected vertex neighbors, we only do it for... Oh, one sec, sorry. Back, sorry about that. Let's see, let's remove that one. Yo, what's up, Fifth Function? Thank you for the raid today as well. I hope you had a wonderful stream, man. Okay, so back to this. We were doing recalculations of the normals in the shader. And yeah, depending on how we do this, we do need or we don't need the object space or world space distance between neighbors. It depends on how we simplify it. I wonder. We can take a quick look at terrain patch. Recalculate mesh data. Here we use the delta. So here we use, here we only use the connected neighbors. So what is it? Up, down, left, right, up, right, down, left. And in this case, we do need the delta. I'm wondering if this is... I remember questioning this when we were doing this as well. Like, if we do 8 connected or 4 connected, do we need... Wondering if we do need the... Yeah, we need the distance either way, I think. Yeah, let's just send it down, and then I wonder, we're probably only going to do the connected neighbors. We're going to do up, down, left, right, up, right, down, left. And delta is dimension divided by resolution 1. Do we have access to delta private? Why not? So we do it like this, and although I wonder, dimension resolution subdivided, we actually have access to it here. So let's just use this one. And do we have... terrain mesh grid delta shader property name? Or mesh grid delta? Something like that. Terrain procedural snow. So now we should have access to this one, and we should be able to calculate normals here. We might do without storing this one as well. We might do all the calculations inside of here. That's a possible solution. Anyway, we want to read rain base data here as well. Displacement height, displace amount. This one we want to fix. So I think we want to do it as positions OS is equal to, or actually input.position os.x plus I times mesh grid delta. And here we just need to do lerp. Then we do need height range here, unfortunately. But we call it something else. We have terrain bounds, but we also need to have... what's up, GDs? Morning. We need to have an additional variable. We need to have terrain data value range. Don't we have a string for this one? G name. So there's a lot of properties we need to set. It's okay. So now we should have this one as well, because what we want to do here is lerp terrain data value range X, terrain data value range Y, base data height. So we're pretty much just recreating the positions of the current vertex and all of its neighbors. Do we want to do it like this instead? And then we do this. It's not perfect, but let's do it for now. And then we want to displace it. So we're going to do position OS 1 plus I, J plus 1 dot Y plus equals to displace amount, height offset. Okay, so something like this. We haven't really changed anything, so I reckon we will get pretty much the same result we had previously. It's just now we have done the pre-work, like we have set up a lot of data we can hopefully utilize down the line. But let's see if everything works as it should. Yeah. Oh no. Should be able to see if we're not sending or binding the correct data, I think, with the offset. The offset still seems to be working, although I would like some better shading for this one. Make it a little bit easier to see if everything is done in the correct way. Harukanen, is it just me or is it really silent here? I hope I haven't been muted by mistake, but watching my instruments here, it looks like audio is getting out, so I sure hope so. Yeah, we still have the working deformation and colorization, so this is good. Now let's see if we can get some normals working, although I wonder if we're gonna do... while testing the normals, I think we want to skip these shadows. So shadow amount. I'm gonna comment this one out and do 0. Because the shadows helps a lot with making things look shaded, or like, let me rephrase that, making things look shaded with the correct normals. If we don't have shadows, fuck, we have the decolorization as well. That's true. So let's do this. Let's remove this one and do float for color is equal to color. Now it will hopefully now you will hopefully see what I'm trying to say here. Harukanen, not you, it's my thing stopped working, it seems. There we go. That is a good question. Derek, everything sounds good here over on YouTube. Nice. Nice. Thank you. Appreciate it. So here we go. We actually have deformation here. But it's extremely hard to see because we don't recalculate normals. So the deformed snow is shaded exactly as if it weren't deformed, right? Hopefully, if we calculate the normals the correct way, we will see some nice shading here as well. So I'm thinking that we might want to do it like... we pretty much want to do exactly this, but we want to do it in our shader. So I'm gonna put it down here. So float 3 normal OS is equal to float 3 this is gonna look messy. Let's just see how it looks. So delta in our case is mesh grid delta times 2.0f times So here we're gonna have to do positions, OS, and then we do left is 0, 1, Y, minus positions, OS, right then is 2, 1. See here, this is going to be rough. Can I simplify it or structure it in some other way? I guess we could introduce... We could do it like this. Let's see. We copy this one, we change this one to float 3. Float 3. We don't do it like this here, we do normalize. Like this, and then we define all of these up here. This one and this one, this one, this one, and this one we can change. Mesh grid delta. But then if we do float left is equal to positions OS 0, 1. Upright, what do we have? Right and up is 0. Down left, so we have 0, and down is 2. Something like this. Giganto, what's up, what's up? Let's try this. We would like to do the tangent as well. For now, we're just going to use this tangent, but here we're going to use normal OS instead. Let's see what kind of result we get from this. Giganto, chilling, how are you? Nice to hear. Chilling is always nice. I'm good, I'm good. And we can see here that we don't get any change whatsoever. Did I forget to do something? Why don't we? Normal OS. Hmm. Hmm. Okay, this makes me think. Mesh grid delta. What am I missing? Is it... Oh, fuck it. Let's do return input dot normal vs. Let's see how that one looks. Hmm. Yeah, I'm not sure about this one. Yes, because we might want to do .y here. Hopefully that helps a bit. Okay. Don't get any recalculations of normals here for some reason. Here. Hmm. Ah. Yeah, what the fuck? We don't want to use screen arams here, not at all. We want to use... we want to use this works for, what are we using these for? Outlines. Oh, yeah. Am I thinking about this? How could this... Yeah, of course. And scene. Yeah. Okay, so here we read a scene texture or outlines texture, and those are in screen space, so that works. But I thought, okay, we don't use this one here. Okay, so pretty much we need to figure out moving 1 pixel on the terrain data texture. What's the distance in UV space for 1 step? And I wonder if we have something similar to that. Mesh grid, terrain data texture, UV scale, UV offset. I'm pretty sure we have done this previously. Terrain data texture resolution. Trying to remember. Actually, we do it in debug. Terrain activity debug shader. Calculate grid. Goes up Ling Ling. What language is HLSL? It's HLSL, I reckon. But yeah, high level shader language. C-like. We used it a lot previously, grid delta worlds. No. Okay, we haven't used it. Okay, this is gonna be messy. I think we're gonna get, or I'm gonna get this wrong, but it shouldn't be. Let's see here, we have the size of the texture. We have the size of the texture. So if we take a look at terrain base data, we have terrain base data size. So we should be able to just do this, right? Terrain base data size. So if we have 256, yeah, it should be like this. How's the game coding going? Depends on what you define as game coding. We're slowly, like, we haven't worked on what people would say gameplay in a while, but I would argue that we actually have. Because this terrain system is going to be extremely crucial to gameplay, but yeah. Right now we're working on, see if we can find it. Interaction displacement solution. So we have implemented a activity texture that stores a lot of data on whatever is happening on the terrain, like if an object occupies a point and how it occupies it, and things like that. And to try out some of this data that we have implemented, we're currently implementing snow. So that's pretty much where we're at. If it's all game coding people are dumb, ignore them. What's up, by the way? And like, in the classical sense, people just have different views on stuff. Like, I've said it before, but like the usual way is to implement gameplay, get a good prototype with boxes and whatnot working, and then you can work on the visuals. But I don't do it like that. Yeah, it has been a while now, but I'm just doing things my way, and we will go from there. Elaine, game coding to me is coding on a game. I agree with that one, and that's exactly what we're doing here. But more specifically, we're coding snow. That's what we're doing today. Yo, what's up, Catboy King? But let's see here. UV step, if we do it like this, I think we should be getting the correct result. So let's check it. And Cypher, thank you so much for the Prime, appreciate it. Means a lot. Derek, Robin, that's the reason I watch. I empathize with that approach because it's exactly what I do too. Yeah, it's the most fun way, honestly. Yeah, what's up, Giganto Mecha? Coming over on Twitch. Yeah, we do. I stream to both Twitch and YouTube. And Ling Ling, yeah, let me school you on game development efficiency. I dislike my game library, so I'm writing my own 2D graphics library. Very effective, totally not a waste of time. I love it. I love what I'm hearing. Yeah, we're implementing our own custom terrain solution here, which is probably some parts is going to be better than Unity, some parts are going to be worse, but yeah. It's important to have fun, I think. Okay, this, I like what we're seeing here. This looks like the normals we want to have, right? Fuck, that was pretty easy. If these are the correct values, they probably differ by some. I think the colorization is good here. I think so. Hope so. Ling Ling, a learning opportunity to me, but most people literally call it a waste of time. Yeah, I don't see... I'm having a real hard time. Like, as long as you code, it doesn't really matter what you code, it's not a waste of time, right? And you, like, I know a lot of people hate or look down on quote-unquote reinventing the wheel, but I think you learn a lot by reinventing the wheel sometimes. Most of the time, actually. Looking like a damn crack field. Running through the LSD fields, yes. I've grown to really like the visuals of when something is colorized by like normals. I think it's a nice... I do like view space normals the most, I think, though. Or like, no, tangent space normals. So the color... I don't remember what it's called, but like the colors you get from tangent space, these colors, I love. I love them. But okay, here we have world space normals. And I think that's exactly what we want. And Cypher needs some banging acid house soundtrack. Yeah, that would be amazing. Ling Ling, I'd argue learning new skill sets is more useful than coding the same thing 10 times over. Nah, that is definitely true. Like, coding the same thing 10 times over, that's what you're doing when you get paid for it, right? GG's, you did it, yeah. Yep. So let's see if we can utilize this one. I'm still a tiny bit skeptical here. Like, it looks to be the correct values, but we might have some... like it might differ, or we might have an error margin here. But let's see what happens if we take this normal and we calculate the lights with it. So we do it like this. That's the software engineer devil in my head saying, quote, I can write it better than all these fools, unquote. Yeah, been there. Mostly for me these days, it's just like I'm afraid of third-party stuff because sometimes they I won't be able to optimize it if I don't know how it was implemented. And sometimes, or usually, I need to tweak it to make it work exactly as I want it with my solution, which makes me need to implement it myself. But yeah. Jay, so what's up? Just clicked onto the stream and that looked sus. Were we talking about the normals? Ling Ling, if I can avoid third-party libraries, I do it. Yeah, same here. Ah, the nude guy. Yeah. But he gets dressed as soon as we play, so that's okay. And we can see here, I think we get the correct lighting. Yeah, I think we do. So we can see here, let's... Oops. It's a little bit, it's lighter here and it's darker here. Just like the character is shaded, so the front here is darker, but we get a lot with shadows. And the back is lit. Yeah, I think that's good enough. But we still have quite a ways to go. But already looking much better. So if we add back, I just want to see how this looks like if we add back changing the color based on how much we displace it. And we also add back the shadow amount. Ling Ling, my end goal would be 2D graphics library that can boot a window where the user, not me, dynamically and interactively build change it. Oh, yeah. I get that. Yeah, Harukan, sometimes we say things that are universally true. But this looks pretty good. It's a little bit too dark, I think. It looks more like you know the snow when it's hovering around 0 degrees. So you have a blend of snow and water. Or when the... Now I'm gonna say more stupid stuff. When the snow is melting-ish. Slask, exactly. That's a Swedish word for it. Lush. Is slush the British word for it? And Ling Ling, I like coding apps, I don't like building UIs. I agree with that one. And no, we don't have yellow snow just yet. Fabik, who usually watches on YouTube, talked about me yesterday about implementing. I don't know if you want to implement the yellow snow as decals or something like that. But we'll see. So what I want to do now, yes, slush is the English name for it. Okay, the more you know. So what I think I want to do now, let's just take a look at this here. Recalculate normals. Yeah, we probably want to do the tangents and bitangents as well. I don't know if we're gonna colorize this snow using textures or normal maps, which we probably are. We are gonna want to have the tangent and bitangent as well, but it should probably be quite straightforward. So I want to do these two, and when we're done with those, I think I want to do this one. And like, I basically want to avoid, I want to avoid the weird peaks you see here. So in this case, we're going to base the height of this one on its neighbors, but that might screw up our normal calculations. So Derek, what causes those peaks? It's just that our, let's see here if we can lower this one. It's basically as simple as that our data, underlying data, is pretty high resolution. So if we check at, if we do ground 1.5, I thought the peaks would be a little bit more visible than this, but it's just that this one is extremely light. These are dark. So it's just that the deformation data here, or the minimum height data here, has a way bigger value than its intermediate neighbor. Let me just show one thing here. Actually, let me bring this one down a bit again. 1.5. Do we have, so this one right here, how does this one look in the snow? Where do we have a peak, a weird peak? This one, can we? Yeah, so that's this one. Yeah, Ling Ling, that's one dilemma. But I finished my exams an hour ago, so I want to have a beer or two. But I need to go pay my respects to a deceased grandparent of my partner later today. First of all, sorry for your loss. And yeah, that is a dilemma. You probably don't want to show up too visibly drunk. Harukanan, fuck it, day drinking is a new sport. Don't want to I don't want to promote drinking here, but day drinking is the shit. Fucking rocks. Yeah, it's a question about being disrespectful. You get a point, you get a point. Cypher, to be honest, we pay respects during a wake, which is usually in a pub, and you get wrecked. That sounds amazing. Ling Ling, I'm building a website for my partner's sister, and every time we meet, we just meet in a bar, have some beers, and talk about all of it. Been there, love it. Cypher, the idea is to have a good old laugh, remembering, telling stories, being with those closest to you, those you haven't seen for a while, mostly family. Yeah, I get the gist of it, and I really like it. Like having a good time, remember the good instead of being sad for the current state of affairs. But yeah, so the peaks we have are, yeah, it's pretty much this. I think the best example is probably when we do, let's take the mattress and remove it, and we remove the pillow. And then we grab this one. We throw it that. So here we can see that we have, oh, it's not that visible, but we actually get lighter parts here, which corresponds to these. And if we render the snow, you get these peak-like things. It's just that I don't think we want to remove the peaks too much, but we might want to blur them a bit or make them not as peaky. I'm not really sad about it. Dude lived an awesome life. Oh, that's nice. That's nice. Derek, oh, that makes sense. I wonder if instead of averaging the data, there's an alternate approach that would more resemble the collapse of the snow. Ooh, that is a good point. Something directional, maybe. Oh. That is definitely true. And Ling Ling, thank you for the follow. Appreciate it. Cypher wondering about footprints. I've also thought about footprints, and I don't know exactly how we would do that. I've never worked with something similar, but And I do like the idea of it. I'm just wondering if it's a little bit too much. I need to set a boundary for myself sometimes. Just flatten the bottom and fake texture it. Yeah, maybe. But okay, let's see here. As for the peaks, yes. So one approach is to just average it a bit. So if we have one point that is way higher than the others, we just lower it a tiny bit. But Derek said there probably exists other approaches that might be better. And Derek, some sort of decal system for footprints would probably be the best. Footprint particles, yeah, we might look into it. I love the idea of footprints. Yeah, this middle peak here is between the legs when we walk. Pretty much what we do when we create the activity data texture is we render from above and we do a minimum check. So what we get is, here we get the foot height, here we get the crotch height. Yeah, I do like this as well. Like, I like it being higher in the middle here. It's just that I might want to lower it a tiny bit. Vintana, hi, are you trying to create like a snow environment? Yes, we are. So if you just normalize it a bit so it's lower than the surrounding. Yeah, like base the height a tiny bit more on its surrounding. But what I'm afraid of then is the normals, but maybe that's okay. We also have the possibility of transforming the actual activity data. But I don't know. So if we would just do something simple as, let's see here. Float 3 position OS is equal to input. Let's just try something very simple here. We do input.position OS.x 0. .z, and then we do position OS dot y plus equals to this one, so we add them all together, and then we do position OS dot y divided equal to 9. So we just average the position. Then we need to use it as well. Ventana, or just make the hitbox of the upper leg a tiny bit larger inside so it hits the floor less. We're actually not doing it with hitboxes. We're doing some rendering magic when we render to a height map, which we then use to displace the snow. Suppose footprint would come in when there's much less snow and light dusting. And that might be true. Like, I do want to explore footprint stuff. Eventually. And I'm gonna need to do quite a lot of research before that because I've never done something similar. We'll get to it. And then we use this position instead. Where do we have it? Here. Okay, so basically what we do now is that we create a position in object space which has the x and z of this one, but for the y, we take the average of it and all of its neighbors. We can probably weight it as well, so that the middle point is or affects the final height a bit more. Good luck on the meeting, Cypher. What do we get now? Yeah, now we get something a bit more like this. We still have some extremely weird shading at points, but I mean, this is already much better. I was anticipating a little bit of a improvement, but not this much, honestly. So what if we do... Yeah, and we have this problem when we do it like this. The seams. Fuck the seams, man. Ventana, did you see the Fron sledge game? It has very kind similar snow effect, maybe more soft. I haven't looked at that particular game, but I've seen similar snow in a lot of games, and hopefully we're going to be able to improve this even more, make it look as good. This already looks pretty damn good. What's up, TM? Nice progress. Thank you. Appreciate it. Derek, if you did want to try something other than averaging, yeah, we can try a few different options. How about this? If height is bigger than average surrounding, push in average direction. Forcing the parts it pushes into to gain a bit of snow back. Almost like the snow is packing down. Okay, so if height is bigger than its surroundings, then we push it in the average direction. And the average direction would be the normal, right? Um, hmm. Yeah, so yeah, let's try it. Let's see if I understand it correctly as well. And I'm also wondering, we can be a little bit more free with that. Right now we're only displacing the snow on the y-axis. I wonder if you would get a way better result if you displace it, if you allow for a little bit of displacement in the x and z direction as well. And then something else I definitely want to fix eventually are the jagged stuff here. Can we do selection wire without? So we're gonna have to flip these quads based on slope, I think. That would yield a way better result in this case. So you would have this instead. I wonder how we are gonna manage to do that though. So it's pretty much we want to flip this one. Okay, but let's see here. So if height is greater than average surrounding, push in average direction. So we could do let's save this one as average position object space. So we would be doing if position os 1.y is greater than average position osy, then we do something here. And what we want to do is push in average direction. Which should be the normal. But we don't want to push it too much. It's the negative normal we want to push it in. So if this is true, let's do Derek, this means if you set the default snow height to be lower than the max, you could cause high ridges around paths carved by entities, which might look realistic. Okay. Oh, yeah. Okay, I get what you're getting. Oh, that would be... like getting high ridges around paths carved would be fucking amazing. But so, if height is greater than average surroundings, push in average direction. Okay, let's see. Or we want to do... The problem I see here is if we think about the peaks we get between the feet, we might need to handle them a little bit different. And there, I was thinking like the direction of motion entity movement, for example. Oh, yeah. Oh, fuck, that would be amazing. And what's up, Bruce? What about lifting points a bit up around legs like you push the snow in that direction? Yeah, that's... is what Derek is getting at, I think. It's very good points. But let's do a little bit of drawing here. And let's see what we're getting at. New... I don't remember, 2560. 40. So it's pretty much like this. If we have if we have the character's legs here, currently we get snow like this maybe. What we're talking about now is getting snow like, let's draw it right above. Yeah, but then I would like to get something like this here. Right, something like that. Am I understanding it correctly? The more I think about it, it really becomes about finding the sweet spot between fluidity and solid packed snow. Yes, indeed. But like if we take this example, a bit smoother here. Yeah. But like, so what it becomes is, how do we identify this case and lower it? And how do we identify this case and heighten it? So for this point, we have more of a surrounding that is trampled down. For this point, we have less of a surrounding trampled down. Bruce, I would say if walking smaller, if running higher, yeah, definitely that would be cool. And we have the data to support that as well. We have the velocity strength. But it's basically like this. So now I'm picturing the person here, or the character, running away from the camera. So what we store in the velocity data is basically an arrow away from this character, or into the screen. And then we have normals here. This one points here. This one points here. Derek, imagine if the ridge in the middle of the legs is spreading itself constantly in the directional movement of the player and also just outwards. Okay, I get it. I get it. Middle ridge left behind the player will fall, but immediately between the player would remain. Yes. Vintana, all the three ridges should come after a general smoother path, totally without the ridges between the leg. And going around the legs peaks, meaning the one on between the legs too. I appreciate all input. I get it. We're gonna have to play around with a few directions. We're gonna play with the normal of the snow and the velocity direction. Maybe we can do something with that. One thing more, or one additional thing, the current way we save the velocity is we don't save the up and down of the velocity. We just save it in the XZ plane, basically. So the movement velocity in its current state, like that's why we're doing all of this snow implementation, because we want to see what we're missing, what we need less of when it comes to the activity data. But currently, we only have the direction in the XZ plane and the strength in the XZ plane, which means that the character standing at a point and jumping don't give us anything. Or actually, we might be getting the strength. That is true. Derek, I imagine the extra height comes from compressing snow getting pushed into. Exactly. So like when you have a person wading through the snow, you always get a little bit of a heightening in front, right? So if we have snow like this, you get a little bit higher here in front of it, right? Because you pushes it around, pushes it up, compressing it. Yeah, 100% get where you're getting at. I just wonder if it's possible to... We don't want this to be like physically accurate. We just want it as a little bit of a visual candy. So we can do... We need to do a lot of shortcuts. And I wonder if we have all the tools for it. What I'm the most... I think if we just focus on heightening it... Combined with some parties would look so good. Definitely. Fucking Red Dead Redemption 2 style. Okay, let's go a bit crazy here. We have normal and velocity in the XZ plane. It makes me think that we want to offset it in the... We want to offset it in the reflected direction of the normal. Or yeah, I think we can play around with the normal here. So this normal is pretty much looking straight upwards, because outwards from the screen and into the screen it has the same height, but on the sides it's lower, so we get a vertex straight up here. So if we get a normal that is straight up, then we might want to lower it based on average height of the snow. In this case, however, we have a bit more of a tilt on the normal. So if we have a normal like this, so if we're in, if the tilt of the normal is roughly within a threshold, then we want to heighten the snow upwards, because think about it, this normal is like this, but then again, what about this normal? Bruce Dam, Red Dead Redemption 2 snow looks so good and real. Do they track each leg position? I have no idea how they do it, but it's like everything about that game is amazing when it comes to the visuals, especially. Such a good start as well, up in these snowy mountains, showing off the tech. But I mean, they do the same thing with mud as well. Oh, it's so great. I fucking loved playing it. I was in awe. So how would one go about differentiating between this normal? So we can differentiate between this and this and this, but the way we do it means that like these two are still the same. How do we differentiate them? Like, how do we want to handle the offset here for this one? But then again, this one is occupied. That's how we can differentiate. This one is not occupied. This one is occupied as well. Oof, it's a lot of things here now, but so we have how occupied something is, binary, the amount of occupation, velocity, direction, and normal. With these three, can we manage to do what we want? Genius, dude. We will see. Like, this is not, I think this is a pretty complicated task, but a very fun one. It's also like we want to implement it with a lot of constraints. We don't want to introduce additional data to get what we want. But let's see here. We're gonna do some testing first. We're gonna render the stuff. I want to render some of these values, see what we have. This one we already have rendered. So this one we know exactly. But it's pretty much like the occupation here. It's minimum. It's whatever is located on the terrain. It's the object space position of its lowest point. So if we have a value there that is anything but 1, we know that it has been occupied at some point. But then it would really need timestamp as well. Because otherwise it would work once, we would get some nice visual effects once, but then the second time around we might not be getting as much or as good of a result if we rely. Vintan, I hope you save all these sketches. I saved some of them, unfortunately not all. But let's do this. Let's start by printing. Let's start by rendering the difference between. We do a dot product between world up and normal. I think the first step we want to do is, it would be amazing if we could highlight these points in some way, render them as highlighted, only like this. This and this, and then we can, if we can properly just highlight these parts. So seen from above, so we have the person here and we have the snow trail here, basically. If we could highlight, sort out these points of interests. So not anything around, but just these and not anything in the trail. That would be amazing. Because if we can highlight those, then we can displace them in some way. So let's start by this is not enough. We need to take this one into account as well. Let's render this first and see what we have. So basically, let's wait with this one. And then we do return dot input dot position worlds. No. Input dot normal world space and float 3010. This is not going to be nearly enough, but maybe. Maybe it will result in a good starting point at least. That's a lot of time. 30 seconds. And also, fuck, this is gonna be a tough one. It's gonna depend. It's gonna depend a lot on so if we would do something like this, if we would base it on neighboring vertices, we could be able to offset this one and maybe this one, but then here it's going to be plain again. So depending on the resolution of the terrain, that's how broad of an effect we can do. But to get around this, we could introduce, if we have MIPS of our activity texture, like downsampled versions of them, we might get a bit more playing room. But and we can see here that these normals are way more aligned with the world up than these normals. But this normal is 100% aligned with the up as well. The strength of the height added for ridges could be based on the average amount of surrounding cells with motion. Definitely. So if we take the MIPS into account, like, let's see if we can render the MIPS. Let's see here. Let's do this, and then we do activity data. Return float 4 activity data height boundary x. Such a fun problem to solve, a thing to implement. So currently we do it like this. Let's try and see if we can render the MIPS of this one. We might need to do some additional setup here. So basically, the activity here is just a texture, where each pixel corresponds to a terrain point, and the minimum height it were ever occupied by. When we do a MIP, we just downsample that texture. So it's pretty much, I guess some variations of the technique is used, but it's basically just an averaging of the texture. So a 512 texture becomes a 256 texture, where each pixel is the average of the original one's surroundings. But we get it for free, or not free, but on the cheap. So let's see if we can render that. I don't know if we have the correct setup here, but let's take a look. Terrain patch. Yeah, it becomes faster than doing it manually, at least. But at the cost of memory, as it usually is. So we have an activity texture here. And we do it by this new render texture descriptor. And we wanna add, I don't know what the default is here actually, but let's see. Auto-generate MIPS, we want to set this one to true. So every time we change it, we auto-generate the MIPS. That might not be the best option. So, because if we take a look at it real quick, when we generate or when we write to these textures, we do it by terrain base. We do it here. So we do set render target, the activity texture, then we render to it, we loop through multiple times, render to it, render to it, render to it, render to it. So we might want to generate the MIPS manually when we're done with it. So down here. But let's jump back to this one real quick, because we need to, so auto-generate MIPS. Auto-generate MIPS, false. MIP count is what we want to change. And here we can define, so whatever, we don't need to, initially we're probably going to set this one to generate all. But we could save some memory. If we know that we just want to downsample it twice, then we can set the MIP count to 2. You want to do use MIP map through, and then finally MIP count to override the number of MIP maps. So if we don't override this one, we should have the default amount. Maybe this is okay. And then we do terrain base. Here we do bloody snow. I haven't really decided just yet what we're gonna do about blood in this game. But I do like the idea, the visual idea of blood in snow. I don't know how we manually do this. Let's see here. Command buffer, Unity, generate MIPS. Okay. Terrain command buffer dot generate MIPS for terrain patch dot activity texture. So basically we render and render and render and render and render to the activity texture for as many objects as we have. And then when we have rendered everything we want, we generate the MIPS. So with this setup, or with this command and this setup, we should have MIPS. And let's see if that is the case. So what we should be able to do, get terrain activity dynamic data. We're gonna have to add, where do we have it? Terrain activity data. We want to have a method here that is terrain activity dynamic data. Get terrain activity dynamic data level. It's going to be float2 UV float level. And then we can just do this. We actually have sample level here, beautiful. And we just replace this one with level. And then here we do return get terrain level UV 0. So level here is the MIP we want, 0 being the default texture, so not downsampled at all. We do clamp sampler here. We might want to do bilinear actually. Eventually. So this is something we can look into as well. But terrain procedural snow, let's add a header. In fragment here, when we output this one here, we do sample activity dynamic data level. Equal to get terrain dynamic level, and here we do sample level. Yeah, let's see if this works. Oh, I missed something. And in a way, since we're taking up memory in this case, like this is like introducing additional data, but it's pretty damn straightforward. What have I missed? Oh, yeah. We might want to put this one on top. this is 0 level. Let's see. If we take the snow and we do sample level 1, we already see a little bit of a difference. Sample level 2. We can probably improve this quite a lot by doing a bilinear filter when we read the value instead of a point. So when we do point, we sample the color exactly at this pixel. We don't do any interpolation. But then we have 3, and we can see here that now we have... Already I'm seeing that, yeah, this can be extremely useful for our use case, I would think. You even get a little bit of a fade. Oh, don't you? Look at this fade here. Oh, this could be... So we could even get, if we get this fade, naturally, if we get this fade, it will also, instead of snow instantly getting trampled, it will... It's almost like we get an animation for free in this case. I wonder if this is the case when we do... So look at this one. Lower it a little bit. Very cool. But I want to try... Let's try and do... terrain activity data. Texture, sampler, and size. And then we do... clamp sampler. We do bilinear. See, we can restructure this a bit so we don't need as much duplicated code. Or repackage, unpack. And then Scale UV, unpack, get terrain, dynamic data level, dynamic data, and then we add. Ooh. Let's do it like this. Let's keep this one as default so we don't break anything. And then we call this bilinear. And the only difference being the sampler we use. Like that, and then we jump back to this one and we do get terrain activity dynamic data level bilinear. Oh, yeah. So what I'm hoping to see here is when we read from a downsampled texture, we get more of a fade or a better gradient. We don't get a pixel perfect value. Am I already seeing it here? I think we are. Yes, we are. So if we go and do, if we do 1, 2, 3, and now we're working with some good values here. And now we can see that we have a lot of selection wire. Now we have a way better spread here. We can see that can we use this data as it is? I wonder. So we can see that this one is way darker. This one is untouched, this point, but it's way darker. So that means that one of its neighbor has been affected or displaced. So if this one is untouched, but its neighbor is touched, then we could just heighten it a bit. That would work for a first time. So that would mean that we would get a higher value around here, around the edges. It wouldn't affect this because these are touched. Although I'm wondering what, yeah, we can see here. We can probably just use this one. I wonder what. Yeah, this is extremely useful. But calculating the normals, or recalculating the normals, is going to be one hell of a task. But I'm sure we will manage in some way. Okay. One sec. We can try and experiment with this just as it is, doing nothing special pretty much. We just offset based on this one. But before I do that, I just need to run AFK real quick. So, be right back. Okay, back. Sorry about that. So let's see what we can do with this simple data. I'm pretty sure. Let's do this. Terrain procedural snow. We have down here we have, oh no, have I? We have displace amount here, great. So, displace amount, main displace amount. So this one is 0 if we don't have any displacement. So we can just do we read this one. Return wonder what happens if we do input displace amount is equal to 0 and activity data dot height boundary dot x is less than 1.0. Should work even with floating point precision, but I don't think we should need to care about floating point precision here, because we explicitly set it to 1.0, 0.0. So what we should be getting here, so a point or a fragment, a pixel will be colored 1 or white if we don't have any displacement on it, but some of the neighbors are affected by displacement. And we base the area for which we look at the neighbors on the sample level. Otherwise, it will be 0 or black. I was so confident when I talked about... Oh, I was so confident when I talked about floating point precision. Maybe we do need to care about that one. But let's see. Maybe not. We'll see. Snow. If we increase the level here, what happens then? But I think I'm doing the wrong comparisons. Yeah, I am. Yeah, I am. Where the fuck am I? Displace amount. Yeah, it's not really displace amount. It's the inverse of displace amount. So if this one is 1, we haven't displaced it. Right. Okay. Getting a little bit of flickering, probably because of the floating point precision, I would guess. But if we do snow here, so we can see here, where do we have it? That we mark the edges, but we also mark some of these. Yeah, that makes sense. But if we were to increase this level, then we can get how big edges we want. And then we have the amount. So in this case, we could make all of this larger or heighten it. Or if we would like this area to be smaller, we can go to 2. And right now, we pretty much do it in a binary way. If we look away from this floating point shit. And that's why we're getting this. But this one probably has a lower value. So let's, instead of returning something binary, let's return amount here. And see if we get a nice gradient. Fuck, this was way easier than I anticipated. It's probably some use case which I'm not thinking about. holy shit, we can get some extremely cool results with this. Hmm. But then again, it depends on how we want to handle it. That, like, this will only work once. The second time around, we can probably come up with something that fixes that issue as well. Okay, so instead of returning 1 or 0 here, we can return, let's do it with a simple branch for now. We do if input dot displace amount is equal to 1.0, or if it's above 0.98, probably want this as a property to the shader, else. In else here we return 0. Else we return how do we want to transform this one? So visually I would like to render visually I'd like to render the amount, like I want it to be brighter if we have a greater value here. Like if its neighbors has been displaced a lot, I want it to be brighter. So the more the neighbors has been displaced, the brighter I want it. The more it has been displaced, the darker this one is. So I wonder if we just want to go return 1 minus this one. Still getting a lot jagged stuff. Also wondering about maybe it's not too bad. I'm also wondering a bit about this. think I would like more spread here. Like in this case, why aren't we getting... It's probably correct, but it's a little bit thin here. I want to check what other option we have opposed to bilinear. Like what I'm getting at here is would like these to be a bit more rounded, I think. But we rely on MIPS and bilinear filtering. I don't know. I don't think we can change any of that. But we could... We could do some calculations, like when we have a UV for a small pixel here and we sample from a large pixel, which I would guess, or which I would call the MIP pixels, we can actually look... We can calculate the offset, like, or the position of the pixel we're sampling. How close to the middle is it? If it's further away, we let it affect it less, and if it's closer, we let it affect it more. I think we could get some rounded corners by doing that. So it's pretty apparent here that... Or am I thinking about it correct? I think so. But what I'm getting at is, let's see if I can draw it real quick. So if we have... Yeah, if we have this texture, original texture, and then we downsample it one level, so we get this texture. So when we read this pixel, we're in the center of this pixel originally, but when we read the downsampled one, we're here, and the center is here. We're quite far away. In this case, all of these are going to be located similar amount away from the pixel. But if we downsample it once more, then we can see here that this one is way closer to the center. These two is a little further away, and this one is way much more further away. So if I could just I wonder if I can use the same logic for my outline. Or my selection highlight shader. Maybe I can. So what I'm getting at is when we color this one, we will color it, or we will highlight it less than this one, and way less than this one. With the end goal of getting a more rounded activity here. I'm also seeing that could probably work. Maybe. But I wonder how that would affect points between 2 pixels or 4. You could also probably average it based on, so we take the average of this. Would it? The average of this and the average of this. Average of this and average of this. I wonder if that would be as nice. And we want to exclude these as well. But, am I just adding a secondary bilinear filtering by doing that? Maybe I am. I'm afraid of what will happen with this pixel right here. This one will get darker than this one. But this one will be darker as well, I think. What I'm getting at is, I want to see what kind of result we get if we do trilinear filtering. Or, what is it called? Trilinear. If I remember correctly, I think this one will filter between MIPS as well. I think. Let's see if we can use it and just see what kind of result we get. I wonder if it's as easy as doing terrain activity data. And we use tri-linear here. We get a much better result at the cost of undeclared identifier. Yeah, we want to change both of these. I also want to... Do we have any other options than point, bilinear, and trilinear? So this is trilinear here. Still blocky as hell. If we sample multiple let's just try a simple thing real quick. We switch these back to bilinear. And then we do train procedural snow. Activity data 0. Activity data 1 plus 1. And we do minus activity data height boundary x. Let's do it like this. Times 1 minus activity data 1 height boundary x. Might be imagining things, but isn't it a tiny bit still blocky? A tiny bit better? Isn't this much better, actually? This one is a little bit rough, but... This looks very good, rounded. Then we get more of a square shape. Also, like, instead of trying to fix this square, yeah, I want to call it an artifact. This square artifact, you could also introduce a little bit of noise. So either that you read from the texture with noise offsetted UVs, or that you take the result and offset it by some noise, then you will get rid of a few of these, where it won't look as square. So that's definitely I wouldn't really call it a solution, but a workaround. Because you want to hide the squariness. But then again, Snow Day, thank you for the follow, appreciate it. Good name. Very related to what we're working on here right now. What I'm scared of with this solution is that what happens if this one has a value of 1 and this one has a value of 0.5. We do a bilinear read. We get more of this one, but this one is still... Or actually, no, we get more of this one, but this one affects it. Feel like the issue we would be getting is maybe I want to try this, but I'm probably overlooking something. I wonder if we will get an artifact instead of blocky. We get an artifact that is circular. So if we have a UV here, we have an initial UV step. And then in this case, the UV step is this. So we want to do... Is it okay to do... Now we get the center point and then we just take the distance. So we need to recalculate the center point, and we do that by taking this UV and truncate it. So we want to truncate this UV to here. Snowday, can you share more about the game idea? I have a short devlog on my YouTube about the game idea. It's pretty old now, that video, but in short, it's the player controls a character. This character has a garden, and then you cultivate and terraform and grow stuff in this garden in such a way that it's nice and livable for creatures that might come and want to live in your garden, pretty much. So think Tamagotchi, Chow Garden, or Viva Pinata. Single player initially. I'm working on it solo right now, and like I definitely do want to have multiplayer, but like co-op multiplayer, right? But it's a little bit out of the initial scope. So the question here, how do we truncate this one to be here? It should be pretty straightforward. We just take this UV divided by one of these deltas, right? And something like that. Awesome. I loved Chow Garden way back when. Me too. Me too. Yeah, we take UV divided by delta round multiplied by delta. That's pretty much it. I do recognize this. So sample level, let's remove this one for now. So basically what we do when we do sample level is float delta level is equal to, we have this one right here. We're gonna have to calculate this one again here, but that's okay. UV step, UV step level is equal to, so if we downsample it once, we get double the distance. If we downsample it twice, we get 4 times the distance, I think. So sample level plus 1 times UV step. And let's try float UV truncated input.uv round divided by UV step level times UV step level. I wonder. And actually we would like to do this first. And then let's try and read the texture by doing UV truncated here. Ooh, okay, that's something is wrong here. What did I forget? Input UV float 2. So we're pretty much working against the truncation, the bilinear filtering here, but that's what I want for now. And then we try, if we bring up the level, yes, we get this. Beautiful, that's exactly what I want to see. Exactly what I want to see. And then we do UV truncated. When we read this activity data, we want to do input.uv. And then we want to calculate a multiplier, which is going to be related to distance from input UV to UV truncated. But this gives us a value that is related to step size. We want this value to be 0 and 1. So 1 if this distance is 0. 0 if this distance is a 0 might be a bit too conservative, but let's try it. So we basically want to do a inverse lerp here. The biggest distance we can have from one UV point to the center is fuck is it? Delta 2 plus delta 2 square root. Isn't it? No, because this is 1 delta, so 2, 2. Right? Let's try it real quick. We want to inverse lerp. This is going to be our t. And we want a 0 here, but this one. So UV step level. Grid. How step level 2. I hope our inverse lerp implementation works with having the smaller number here, but let's try it. Ugh. Two param. Oh yeah. We don't want to do plus here. We pretty much get no improvement with this one because we don't use the result multiplier. Ooh, this is looking... yes. Oh. I think what we're seeing here is this artifact. Let's see how it looks with bigger... Force. Of course. Cool. Yo, what's up, GG Sammy? Did you get everything working in Unit 6? Hell yeah, we did. Yeah, this solution sucks. For multiple reasons. Although I wonder... I want to try one thing. We're probably going to get the circular artifact either way, but... this one, we calculate this the wrong way. We want to calculate it as to the power of its exponential. So we want to do... So this one, sample level, we want this one to be calculated as power 2 to the power of sample level. 0 gives us 1. 1 gives us 2, 4, 8, 16, and on and on and on it goes. GG Sammy, nice, yes. It was, as I anticipated, pretty much everything we needed to do was related to the custom renderer features, so the outlines. Everything else went pretty smoothly, pretty much automatic. Yes, I should have anticipated this from the get-go, but I'm wondering if we're onto something. The trilinear filtering definitely gives the best result just right now. Snowday, I do this part-time, and then I'm in... And then I do some data-related stuff on the side. Or the other part of my time. I know that we, like... As I said, we could work around this with some sort of noise. Noise offset. It's either we offset the height difference or the UVs, or but like that's our plan B. Plan A would still be to round this in a nice way. De-squarify the result we're seeing here. But yeah, we don't want that to be too costly. How could we go about doing it? I'm gonna have to think about this one, ponder it for a bit, because I think it's time I gotta run. But damn, to summarize this session, great progress, great input from chat, love it, both chats. And we will continue it tomorrow, if nothing unforeseen happens. And I don't want to give up on trying to round this just yet. I'm not really ready for it just yet. But we'll see. So thank you so much for watching. Derek, awesome work, bro. Thank you, appreciate it. Appreciated you being here as well, all of you. Future Rockadoodles problem, exactly, Cypher. Yeah, what's up, Fluffy Zombie? Yeah, appreciate you all. Have a great rest of the day. Peace.